Ada, Prof.
Yes. Okay, thank you. 1 minute. Okay. Okay, thank you, Nazirah or Dr. Nazirah or maybe Miss Nazirah. Okay, Bismillahirrahmanirrahim. Alhamdulillahirabbil alamin. Wassalatu wassalamu ala sayyidina Muhammadin asyrafil anbiya wal mursalin wa ala alihi wa sahbihi ajma'in. Assalamualaikum warahmatullahi wabarakatuh and good morning to all of you. So first of all, thank you very much to IFSIS for the invitation to share some of my experience, knowledge on research methodology. So I can see that you have experience listening to talk given by actually Prof. Engineer Dr. Rumaiza from FSPU, and I'm Ismail Musirin from School of Electrical Engineering, College of Engineering, UITM Shah Alam. So I am speaking from level 18, Menara 2, Menara 2 Complex of Science Technology, UITM Shah Alam. So I'm from my room. So I hope no disturbance in terms of internet connection, because sometimes the connection is on and off. So to IFSIS for the invitation. So I was given a task to talk on PhD research methodology, and I am basically adding a subtopic on it, and I call it as a scholarly journey. Okay. All right. So this is a bit of my CV. So you can have a look. So far, Alhamdulillah, I managed to graduate 36 PhD graduates, 23 master's graduate, and currently I have 17 PhD students and 1 master's student. And you can see my H index over there and some of my experience, CV, and so on. And those are the journey of my career in UITM. And then I got my PhD proposition in 2014, and I'm here now. I've been in UITM for 32 years in academic life. Okay. So please call me if my internet is disconnected from the system. Okay, this was my experience. I got my PhD from UITM. I happen to be PhD candidate number 7 of the whole UITM system, and you can see that my hood is a bit different as compared to the rest of my friends. So they are all PhD graduate from Faculty of Architecture, FSPU. Same faculty with same college with Prof. Rumaiza. Okay. So just to share a bit about the journey of PhD, we start with first degree, with which we have 1 line on our gown, and then 2 lines for the master's degree and 3 lines for the PhD degree. So you cannot stop once you have step your feet, so you cannot turn back. So don't stop in this. All right. So this is just to refresh back for students. So once you have got your PhD, or I mean, once you have passed your PhD Viva and you have submitted your hard copy or your digital thesis, so you will see a big day. The day is called as holding ceremony, the day before the convocation day. So convocation day is normally conducted on held on Saturday, and 1 day before, I think Friday afternoon, graduates and the supervisors will experience holding ceremony. So supervisors will receive certificate on the top over there. Okay. And this is a bit to talk about the knowledge continuation, the sanad. So I was supervised by Professor Dr. Titawa Abdul Rahman. She is currently at Asia University, Subang Jaya, Selangor. And Professor Titik Hawa Abdul Rahman was supervised by Tan Sri Gauss Jasmine from UM. So you can see that my standards from UITM going to UM, and Tan Sri Gauss got PhD from City University London. Okay, these are all my current PhD students. I think I got about 16 or 19 PhD students, 16 students right now. And you can see these are all my PhD graduates, 26 altogether. And Alhamdulillah, I got experienced rezeki. 3 of my PhD students passed the PhD Viva without correction. The first one is Dr. Zulkifli Uthman. Second one is Dr. Azwa, Sharifah Azwa. She is a lecturer at Uni10. And the recent one is Dr. Nulaili Ismail from UPNM. So Dr. Nulaili has not gone through the convocation day. These are all my master's graduate. And when we talk about PhD journey is something very bitter actually. It is actually more bitter than the bitterness than the sweetness. So you can see that sometimes you are in the middle of the dark tunnel. Sometimes your supervisor give you a torchlight, but you don't know what to look for. And if you are in the middle in the dark tunnel, so you need to get back to your supervisor. Don't make yourself disappeared, or don't try to keep quiet in your own cabin and so on and so forth. But it is actually worth to get a PhD. So before we talk about PhD research proposal, PhD research methodology directly as the main syllabus for this morning syllabus. So allow me to talk about a bit on research progress, on research proposal. So I happen to be one of the panels at Ministry of Higher Education, MUHI or KPT, Kementerian Pengajian Tinggi, Putrajaya there. So I am a panel of FRGS, PRGS, TRGS, LRGS, and we can have proposal to be prepared. So your proposal will depend on the nature of the research. So you are now writing your research proposal. I believe that. And on top of that, you will also learn about FRGS research grant, PRGS prototype research grant scheme, LRGS long-term research grant scheme, TRGS transdisciplinary research grant scheme, industrial research grant, dana kecemerlangan and FRGS, it can be PRGS, it can be combination of FRGS and PRGS, or even it can be a part of LRGS or a part of TRGS research grant. But I normally, when I give talk to students, I give talk to new supervisors. So we basically, I basically don't encourage our lecturers or our supervisors to request their student to write proposal on their behalf. Okay. Okay, so when we talk about PhD, we are talking about PhD novelty contributions can be fundamental or applied. When we talk about PRGS, we will talk about workable prototype, unique, then the market product, no need for fundamental element. For TRGS stands for Transdisciplinary Research Grant Scheme, must have novelty contributions, can be combination of project from several disciplines within the same university. That one is TRGS. And the limit of the ceiling for TRGS is, if I'm not mistaken, is 1.5 million. And for LRGS, the limit is 5 million. And it has a combination between fundamental research grant as well as a bit applied. But this one is actually concentrating on a combination from scholars or research scholars from several universities. So minimum, the LRGS will require 3 universities to be sitting together to prepare proposal and to do their research for LRGS. This is 5 years research project. And e-science is basically applied research must be workable product as the deliverable. And my lab is another research nature offered by KPT or MUHI, and is applied research in nature for research product to be commercialized. So your PhD can be one of those or combination of all. Right? So that one is a PhD research project. Okay, when you talk about PhD proposal, we are actually talking about research novelty. You need to translate objectives to novelties, and then we need to do validation process. We need to experience a verification process. We need to perform comparative study, and you need to be there to defend your research work that you got novelty or PhD contribution. And then it has to have adequate breadth and depth, kelebaran dan kedalaman. And in UITM for PhD, the AIPSIS requires 2 publication. So for the old cohort, I think the latest one also they need 2 journals. So but my benchmark, I will request my student to publish minimum 2 WS or Scopus Index journal, otherwise their PhD thesis. Okay, perception on PhD. So when you talk about PhD, people sometimes said that PhD is actually a permanent head mission. Could be right in a way, but on the other hand, the more technical definition is that it is actually a perseverance and hard work. Yeah, so that is PhD. It is a process basically. It is a process to uphold your martabat, your dignity, so that you can become an independent researcher at the end of the day after you manage to get your scroll your PhD degree. Eh? Okay, just to talk a bit about PhD process. It is actually outstanding ability to conduct and to produce an academic research output. Eh? As I mentioned to you just now, at the end of the day, once you have got your PhD degree in your hands, so you will become an independent researcher. You can make a decision whether this is going to be a master's degree, whether it is going to be a PhD degree, or this is only a first degree project. And then it will involve learning process in academic research, developing skills to generate new knowledge, training to write an academic report, learning to traits of scholars, apprenticeship in academia, and sharpening in academia. So when you do PhD, you will experience, you will undergo writing research proposal, you will undergo developing or formulating research objective, identifying research problem statement, objectives, and so on and so on. That's why we call it as problem statement, problem identification, and so on. Okay, so the school of thought for a PhD. So when you Google, so the answers can be very, very broad in a way. So when you talk about a PhD school of thought, it has to have adequate contributions to the body of knowledge, to the pool of knowledge. This one I also learned from my supervisor. I also learned from Professor Harun Ar-Rashid from Western Florida, USA. And when you talk about PhD, we are actually talking about PhD novelty. Sometimes the research are applied. Sometimes the research are solving industrial problems. Sometimes the research are research, but not a PhD research. So that's why we need to have adequate contributions to the body of knowledge or to the pool of knowledge. That's why we have to talk about novelty, PhD novelty, PhD contributions, and so on and so forth. Eh? And then we need to talk about validation process. We need to perform verification process. We need to verify that knowledge is correct. At least 3 main contributions to the body of knowledge with adequate breadth and depth. Yeah. Okay. So going back to review, to get the understanding of 3 degrees in the world, starting from first degree, a bachelor degree. So journey of academic degree for first degree, we don't have to produce or we don't have to come out with a research novelty. So no need lah. So if you're a supervisor, then if you're a panel, then you ask the students, you got no novelty. So that one is too much. So first degree, no need to have research novelty. But they can redevelop the previous product. No need for research novelty or new contribution. But for engineering, I'm from electrical power engineering. So we need to have element of design analysis, simulation, experimentation, hardware, programming, and so on and so forth. Then all those will be encompassed together in the degree of FYP or final year project. That's why in final project, we don't call it thesis, we call it final year project report. Okay. The school of thought for master's degree by research. So the school of thought is that it has to have at least one contribution to the body of knowledge. One contribution to the body of knowledge or to the pool of knowledge. And with adequate breadth and depth, it has to be validated, it has to be verified. And in terms of benchmarking, I normally request my students to have at least one journal published from their master's project, from their master's degree. Okay, index journal either in WS, Web of Science, or Clarivate Analytics, or Scopus. Okay, get back to a PhD research definition. The school of thought is that at least 3 contributions to the body of knowledge, adequate breadth and depth, validated, verified, and the benchmark is going to be either to ISI or Clarivate Analytics Index Journal or Scopus Index Journal. But it is not a must in UiTM, but I make it compulsory to all my PhD students. Okay, let us discuss a bit review about research definition. The research definition which I extracted from the source, reliable resource. It is defined as intellectual and creative activity carried out on a systematic basis in order to discover or prove or find evidences about something new or unknown. That means When you talk about research at a PhD level, it has to be systematic. It has to be, sorry, allow me to come up with my laser pointer. Yeah? Okay. It has to be systematic. It has to be organized. It has to be database, scientific inquiry, and critical. So that's why it cannot simply end a normal observation. When you talk about PhD research work, you need to have all these components together. Yeah? Component together so that at the end of the day, you're going to talk about developing a solution to solve the problem. That's why you need to put right side by side problem statements and objectives so that the objectives will answer problem statement and vice versa. Okay. So this is actually the circle of research. All the processes or components in a research answer, each other, they form a closed loop. So let's say you start with title, then you followed by the problem statement. But normally, my student will not start with title. My student will normally start with the objectives. So objective means I discuss with my student what we want to come out in the first place as our first novelty. That's why in PhD research work, novelty is very important. So now objective need to be formulated wisely, cleverly, or clearly, or explicitly, so that the objectives will be there to answer the problem statement. When you put side by side the problem statement and the objectives should be able to answer directly the problem statement. But not necessarily you need to have three problem statement and three objectives. You can have three objectives and two problem statement. You can have four problem statement, three objectives, and so on. Normally for PhD, we require three novelties or three objectives for PhD. But of course, at masters by research level, we can have complementary objective. I will show you some example later, the examples of PhD objectives or master's objective. After you have formulated your objectives, then you will go to methodology, which is going to be the main issues to be discussed this morning. And we are going to take this out from the whole spectrum here, and we discuss what is going to be the inner part of the methodology, so that at the end of the day, you will be able to say that, oh, this is a proper research methodology for your PhD research work. Then from there, you will be able to identify, you will have the guts to say that, okay, this is my research novelty, and so on and so forth. So starting from the objectives, we will go to the next phase, which is the methodology. Methodology will be the process to explain how are you going to go about in reaching your objectives or in achieving your objectives. So then you will follow with the experiments. It can be simulation, it can be modeling, it can be hardware experimentation, data collection, and so on and so forth. It can be on the computer desktop, it can be on the laptop, it can be in the wet laboratory, it can be at the dry laboratory, it can be anywhere, as long as you can get experiment, as long as you can really experiment with methodology and objectives, and the results should be able to answer the objectives. That's why you can see the direct arrow anak panah from the results going towards the objectives. So along the way, you will design the methodology to make sure that your methodology will be able to produce the expected result. And then after you got the result, you can do analysis and discussion. That's why it is very sensitive. It is not allowable for my student to put analysis on the title of your PhD research work. Okay. And then after you have got results, you do analysis, you discuss, and then it has to answer the problem statement. At the end of the day, the title will be very global in order to represent everything on what you have done in the past 3 years, 4 years, or whatsoever. And the conclusion need to be able to answer objectives. So you can see that they are answering each other. You can have errors from objectives to the problem statement, errors from methodology to the problem statement, to the title, to the experiment, to the title. Results will answer back objectives, and methodology will answer back objectives, and results should be able to answer objectives, and so on. So they are actually correlated each other. Title, problem statement, objective, methodology, experiment, result, analysis, discussion, and conclusion. All right. So these are example or category of PhD research. It can be development of new technique, novel application, more algorithmic extension of existing new technique. So those are the possible natures in a PhD research. It's not normally only on the observation. So when people ask you, you are doing PhD, what is your first research novelty? Then you need to sit in front of the laptop or in front of the mirror, ask yourself, what is my first novelty in my PhD research work? Are you just doing investigation, or are you just or are you developing something new which you can claim this is going to be my research novelty? I will show you example later, inshallah. Yeah, I will show you later. Okay. Example, let's say you are experiencing a scenario like this. Let's say you got no database. If your data are not systematic, if observation only involve in data collection, if you got summary of a list of papers, list of books, and so on, or thus doing the analysis, they are not research at the PhD level. It can be research to solve problem industrially, maybe. It can be research, short-term research to solve immediate problem, but not going to be called as a PhD research because you cannot see novelty over there. Yeah? That's why if you only have all these components, but if you got no novelties, they are not called as PhD research. Yeah? Okay. For example, so since I'm coming from electrical power engineering, or electrical engineering, we have a high voltage engineering, and in the high voltage, we can see Cockcroft-Walton stack to uh, get high voltage DC, and maybe you can see development of charge converter, development of boost converter, application of NN for voltage stability study, or analysis of NN for voltage stability study. These are all not a PhD title. Why am I saying that? I am saying this because these are all already available in the textbook of power electronics, available or appeared in the textbook of high voltage. So not a research, already available in textbook, no research element, no novelty, only development and nothing new. The last two at the bottom here, analysis of NN for voltage stability study, it can be a paper title, but it is too simple for a PhD. It is only suitable for a degree, first degree. Okay. Okay. Let's talk about the next one. Let's say you start with Cockcroft-Walton stack, and then you develop or derive a new model in high frequency domain. And on top of that, you derive a new equation to represent the model and all the parameters. And then you embed inside there artificial intelligence or computational intelligence technique to solve the problem, and you solve the traditional problems. All these, when you embed them together, it can be a part of the PhD research novelty. Starting from the Cockcroft-Walton stack, which we just now discovered from the high voltage book. But from the high voltage book, when you have included additional novelties or additional research element there, it can become one of the PhD contributions. So this is the way how we can go about in our PhD research book. Okay, let's say from charge converter, then you develop control circuit topology, and then new switching techniques, new application with model configuration, hybrid with other topology. It can also be called as a part of the PhD novelties. So maybe you find it in a title in a power electronics book, and then you extract that one, you do something, you put added value inside that, you put topology and so on, and then you basically can call it as a part of the PhD research novelty. Okay. So we talk about defense officer proposal. So you have a cycle between supervisor and student. So student follow the deadline. Okay, supervisor normally gives the proposal of his past student as an example. Student follow the deadline, just do it. No worries. Don't feel small if it has to go several rounds. So what I mean is that sometimes you need to submit your proposal to your supervisors many times. Not only first cycle, it can go up maybe up to 3 or 4 cycles. But this is actually a big responsibility. You must be feeling very grateful if you can find a supervisor who is able to read your research proposal, to read your papers, to read your thesis word by word, sentence by sentence. So you can see that at the end of the day, your proposal should be 3 to 4 problem statements, must be related to the objective. So that is your research proposal. And then it has to have 3 to 4 main objectives, must answer the problem statement between 20 to 30 pages, not too much, up to 70 pages. No need to do that. Depends on your supervisor, and references can be between 50 to 100. Okay? So this is actually the circle, the correlation or communication, active communication between students and the supervisor. Okay? Okay, when we talk about research journey, so we will be talking about it is based on the work of others. So that's why we start with the benchmarking. Sometimes when you do research, you start with the work conducted by the previous researcher. You start with the work conducted by your supervisor or by your senior. Then you from there you get idea, you explore further, and then you identify problem statement, objective, new novelty, and so on. That's why it is based on the work of others as well. That's why you are actually referring. You are not entirely doing something new per se. No, it can be replicated. Why am I saying that it has to be replicated? That means other researchers can replicate the results or can replicate the experiment, the model, and so on. And then if they replicate, they use the same model. The model should be able to produce almost similar trend of result. That's why we call it as replicable. Right? It is too generalizable to other. I mean, it is normal standard. It is based on the some logical rationale and tied to theory. It generates new equations or is whatever you do in your research work, you must have background at the end of the day, background study. You must have the explanation behind it. You must have the theory, assume something without no base. That's why. So otherwise, it will not be called as a research objective in your PhD work. It generates new question or is cyclical in to political. Right? Okay. So what is this in your research work? The opposite of what you have discussed. Looking for something when it is simply is not to be found, plagiarizing other people's work, falsifying data to prove point, and misrepresenting information and misleading participants. So all this need to be avoided by us as a research scholar. Opposite what we have discussed. That means when you find something out there based on the journal, based on the technical paper or whatsoever, so you shouldn't be doing something opposite with that nature. Okay. No need to please don't plagiarize somebody else's work. I understand that now we got tech GPT, we got AI, and so on. So we can understand that you can simply get resources out there with very fast. So be careful. Don't plagiarize other people's work. Okay. So now I would like to talk about the difference between qualitative versus quantitative. So qualitative is going towards naturalistic, focus on understanding, descriptive, flexible methods, inductive, and richly descriptive. And quantitative is more statistical, focus on predicting, controlling, hypothesis testing, predetermined methods, deductive, precise, and numerical. So you will learn this in somebody else talk later on, the difference between qualitative and quantitative. Okay, the difference between research activities in the engineering disciplines and others. Engineering research are more formulative in nature. That means in engineering or in technical, in computer sciences, we are basically doing something based on formulation and so on. Lot is based on mathematics. Experiments are conducted on machines rather than humans or animals, unlike the pharmacies, the medical background or whatsoever, which will be based on animal, humans, and for social sciences, they will get opinions or recipients from the recipients or a data supplier and so on. And then data to be collected differ significantly. So our data can be from the reliable data source. We can also generate our own data based on the experiment we conducted or vice versa. Hypotheses arrive at the largely based on the mathematical proofs rather than just an educated guess. So it has to be mathematically proven, then only we can come up with hypothesis, and at the end of the day, it can become a theory, eh? Because hypothesis is unproven theory. A period of time, outputs are more tangible, such as software, new machine, or components, or even mathematical equations. So that's why when in science and technology, we talk about novelty, we talk about model, we talk about framework, and so on. Engineering research do not differ much in different regions of the world. Eh? I mean, if you do research in UITM, and if you discover that somebody is doing research in Canada, Waterloo University, Canada, so the nature of the trend of the result would be quite similar. Eh? So that's why it has to be standard in a way. Okay, then we talk about research framework. Eh? As part of the important things in research circle, when we talk about research framework, this is actually trying to extract something important from the research methodology, from the methodology. So from there, we will understand what is research design, what is research framework, what is the difference between research framework and flowchart. Two different things. Eh? So research framework is trying to demonstrate the correlation between problem statement with objectives, activities, test specimen, deliverable, expected novelty, and so on. That one is research design or research framework, whereby flowchart is a process to explain the process. For example, explaining the algorithm for evolutionary programming, genetic algorithm, example, particle swarm optimization. All those are to be embedded in a flowchart. I will explain to you the difference later between research design and research framework, or research framework with respect to flowchart. Okay. So research design or framework in general, research design should be able to demonstrate adequate breadth and depth of your study, either in PhD, Masters, FRGS, PRGS, TRGS, LRGS, RACER, MyLab, eScience, etc., etc. That is research design. Research design is not presentation of flowchart of your algorithm, such as ANN flowchart, BSO, EEP, and so on. Research design should be able to demonstrate the correlation, as I mentioned to you just now, correlate between this problem statement with this objective. That one is research design. With respect to objectives, activities, and expected deliverable and novelty, research framework should be able to show that all objectives can be successfully achieved. And then from there, you can see the test specimen, the size of data. Is it going to be small data size, medium data size, or even larger data size? Maybe in power system, you are going to use a small model, medium model, or larger model. This is example of research design or research framework, general arrangement or correlation. If you like it, you can take it and you can just change the inside things components of each component. So I'm showing you here one example of possible research design to show your breadth and depth of your research work for your PhD or master's by research. On the very left column, you can see problem statements. Problem statements, you start with problem statement 1, problem statement 2, problem statement 3. The second column, you got the objectives, objective 1, 2, and 3, and activities, you got activity 1, 2, 3, 4, and so on until activity K. And you can see that objective 1 can be answered by problem statement 1. Or even objective 1 can be answered by problem statement 1 and problem statement 2. Objective 2 can be answered directly by problem statement 2, or objective 3 can be answered directly by problem statement 3. This is one unique or one typical example. But it is not wrong for you to have objective 1 to be answered by problem statement 1 and objective 1 to answer problem statement 1 and problem statement 2. Or objective 2 will answer problem statement 1 and problem statement 2, and objective 3 will answer problem statement 2 and problem statement 3, or even objective 1 will answer 1, 2, 3 together, and so on. But they are actually non-planar and so on. On top of that, in order to get the experiment result and so on, you need to have activities doing the experiment, developing the network, developing the model, developing the topology, and so on. Those are our activities. And then conducting experiment in the laboratory for maybe activities, let's say for social science, they need to collect data from human And then you need to maybe to have the Google form and so on. This is also activity. But you develop model is also an activity, but the model is actually a unique objective. Right? And then on top of that, you can also have test specimen 1, test specimen 2, and test specimen 3. So that at the end of the day, you are going to come out with the first novelty, second novelty, third novelty, and so on. So they are all embedded together in a research design or research framework. Yeah. Okay. This is one example, one typical example. This is another example. Okay. So this is another scenario. Problem statement for PhD. Normally, we should have 3 main problem statements. Eh? And then for masters by research, 1 main problem statement and followed by complementary problem statement. For formulated objective for PhD, we should have 3 main problem, 3 objectives, which will answer 3 problem statements. And then for master by research, we should have 1 main objective followed by the complementary objective. So to be in a very short form, I would like to say that in your PhD research work, you need to be able to identify 3 main novelties. In master's by research, you need to highlight your 1 novelty. So let's say your first PhD novelty is developing a new equation. That is novelty. Novelty number 2, maybe you are going to develop a new model. Second novelty. Number 3, you are going to develop a new theory or equation. That is also a novelty. But in masters, you develop a new theory, you test it, you validate, and then you do comparative study. That one is good enough for masters by research. But PhD, no. So that's why in PhD later on, I will show you example of suitable objectives based of my experience as examiner. As of now, I have read about 150 theses at PhD level and masters by research. Right? So your objective should be able to demonstrate adequate research novelties for your PhD or masters by research. The breadth and depth must also adequate. Okay, this is qualitative research versus quantitative research. So this one you can simply go through. Yeah. And then it can be a mixed method between quantitative and qualitative as well. So now I'm going to show you one example. PhD problem statements as compared to objectives and novelty. You can see that problem statement 1. So we go to objective number 1. Objective number 1, to develop a new technique termed as chaotic mutation immune evolutionary programming, CMIEP, to solve the maximum loadability in power system. This is novel. Why it is novel? Because when you Google chaotic mutation immune evolutionary programming in Google, you will not see. Okay, this is from my PhD students. So, but if you Google chaotic, you can see chaotic as it is. You can see mutation, you can see immune. You can also see evolution programming. But when you put them together to become something new which you are proposing, you are basically not to be able to find it in Google because it is actually new and novel. Right? So what is the problem statement? The problem statement is, in this case, most current optimization techniques have failed to produce globally optimal results. To solve optimization problems, the solution is trapped in local minimum leads to low quality results. So that means we need to develop a new technique. We call it as CMIEP, so that CMIEP can solve problem addressed in the first problem statement. Okay, that's why I call it as problem statement, problem identification or problem formulations. Okay, rumusan permasalahan, pengenal pasti permasalahan, or maybe problem statement permasalahan. Kenyataan permasalahan. So this is how you call it, problem statement, problem identification, and problem formulations. Objectives number 2, to integrate the chaotic local search. Number 3, to formulate a new technique termed as Pareto multi-objective chaotic immune evolutionary programming to solve multi-objective problems. So you got problem on the left side. And the last one, to derive a technique for identifying clustered areas that are subjected to DGPV, blah, blah, and so on. So these are all examples in PhD research work. But if you do masters, 1 is enough. The rest can be complementary objective, which I can show you later on. So novelty, development of chaotic mutation immune evolution programming as optimization engine. Number 2, formulation of chaotic mutation immune evolution programming with chaotic local search for optimal DGPV insertion planning and so on. So those are all the novelties. So you can see that objective need to be novel in a way. Okay. This is another example for research framework. you got a problem statement on the left, you got objective in the middle, and you got a validation process, comparative study. Why we need to do comparative study? If you do something new, let's say you develop a theory or you develop a model, you need to test your model. When you test your model, you call it as validation process. The purpose of validation process is to make sure that your model or your theory or your equation will be able to produce results as you wanted or as you expected. That is validation process. On the other hand, when you talk about comparative study, we do comparative study in order to highlight, in order to evaluate whether your proposed technique, your proposed model, your proposed algorithm, your proposed equation is better or worse than the available technique, model, topology, equations, or framework. You understand? Example, like I developed a new equation. So to challenge Ohm's law. Ohm's law said that V equals to IR, for example, or maybe Faraday's law, EMF induced equals to negative N d flux by dt. Or maybe Newton's law, F equals to ma. So I develop a new equation. Maybe F to the subscript alpha equals to ma squared gamma squared plus 1 minus zeta squared a squared x1 blah blah and so on. So I develop my new equation. That one is novel. So if you manage to get result as you expected, that one is validated. But when you do comparative study with respect to the original Ohm's law, original Newton's law, and so on, that means you are comparing your proposed equation, model, techniques, topology, and so on with the available benchmark technique. For example, you got particle swarm optimization. I developed something new, beginning from the particle swarm, which I embed together with grasshopper. So I call it as integrated hybrid or hybridized swarm and colony evolution programming. So I embed this together. So I challenge with the original particle swarm. I compare with the original evolution programming. I compare with the original PSO and so on. That one is comparative study. So we need to make sure that our proposed technique wins, yeah? Okay. And then you do the test system 1, test system 2, and so on, to get the result. And then you can translate into conference paper, journal papers, thesis, intellectual properties, and so on. So this is a research framework. All right. Now we talk about example in PhD lah, yeah. This one is knowledge acquisition. And you also got development, you got objective 1, objective 2, and then you got here objective 1 to 3, So you got, this is all example of PhD research work lah, yeah. So this is called as research framework. This is the next example of research framework in a PhD research work. This is another one, comparison. You put the problem statement and objective side by side. You got objective to formulate a new hybrid optimization technique termed as immune conventional evolution programming ICEP for solving a research problem. This is objective number 1. So what is novel? Novel is the equation, ICEP technique. And then this one is problem statement 1, most traditional optimization technique, experience problem as the being trapped at the local optimum. That means we would like to solve problem experience in the first problem statement, and this one need to be answered by the first objective. So when you compare objective and problem statement side by side, you can see that objective should be able to answer the problem statement. Okay, this is another research framework example, and then this is another research framework, and this is another example of this framework. This one is extracted from my PhD student's thesis. This is from Dr. Hatta from Unimap. You got a research objective on the very left column to develop new algorithm for overcurrent relay coordination. This is new. What is the approach? Design new optimization technique. Identify still objective function, do the setting and so on, activities, develop loop flow program. All this is something that you must do. That's why when you collect data, you do experiment. That one is not novel. That one is only activity or scope of work. And then the outcome will be load flow for 8 bars, 14 bars, and so on. Those are outcome and so on. So this one is FRGS. If you got something like this, inshallah, you will get for your you get it right. You get it right for the FRGS methodology component. This is another example. You got still objective on the very left column, research approach, activities, outcome, and so on. This is another example. Okay, this is another example, complete example which will represent the research framework. You got objective 1, objective 2, objective 3 on the very left column, but at the top there, you got knowledge acquisition. What is knowledge acquisition? Knowledge acquisition is a process to get the basic understanding of the power model, voltage stability, and so on. It's not only limited to literature survey. Literature survey is a part of the whole work under the knowledge acquisition process. So you can see that multi-area voltage validation. And so if you like it, you can take it and fill in the blanks, make it adaptable or adoptable with your research proposal or research work and so on, with complete breadth and depth. So this is another example. You got research framework for master. This is for masters, but for masters, the objective is not novel for second and third one. Only novelty is required for the first objective or masters by research. For the first objective, novelty is only one, yeah, to be embedded. Okay, this is flow chart. Research framework demonstrate the breadth and depth of the whole research work. Broader scope presents the correlation among all the components. Does not show the detailed flowchart of the developed algorithm. This is a research framework. On the other hand, research flowchart presents the detailed process of any algorithm. Example, Kuko search algorithm. Verify, explaining the pseudocodes does not show the correlation among the research process and so on. So you can see the difference between flowchart and research framework. Okay, this is just to share my 3 students underwent the graduation process in 2022. 3 orang graduate lah, alhamdulillah. Dr. Helmi, Dr. Sharifah Azma from Uni 10, Dr. Hatta from Unimap. Okay. Okay, get back to the syllabus. This is example of flowchart. This is not a research framework. Yeah, so you can see that this is flowchart. Flowchart is not research framework. This is also flowchart. Flowchart is not research framework. This is framework. This is framework. Successful FRGS proposal. I got 88,000 only, not much, but I got
Sorry everyone. Prof Ismail line disconnected. I will try to contact him. Wait a minute.
Okay, so sorry saya terputus tadi. Nazira, saya dah lama keluar ke? Kat mana tadi? Halo Nazira. Can you hear me? Mio, can you hear me?
Ah, yeah, Prof.
Yes, Prof.
Okay.
Prof,
Saya
line
ni
Prof
kat Tegalan 18
putus-putus
kadang-kadang
lah,
dia
Prof.
terputus. Okay, kat mana yang saya tertinggal tadi? Ini okey ke? Masih terputus ke? Hello?
Okay, okay, okay.
Dah okey, Prof.
Ini saya tak sengaja boleh gunakan saya punya apa tu connection. Okay. So sekarang boleh dengar kan Nazira?
Boleh, Prof.
Okay, thank you. Okay. Just now I was talking about research framework. I'm not sure which one in which slide I was disconnected from you. So just to refresh back, so we got this one. All these are examples of this one is research framework. This one is the comparison. This one is flowchart. This is flowchart. This is a research framework. So you can see the difference between flowchart and research framework. This is another example of research framework. This is also research framework. So you can see a comparison between the normal people. Sometimes people like to do on the right side, which will show you the one process flow from the top to the bottom. So there is no returning path. There is no correlation among all the components. So if you have something like this, no need for us to draw diagram because this is not a framework or not a flowchart at all. So better to use. I understand maybe some of you are lecturers. So people like to use something which is very comprehensive, which I normally use the yellow one on the left side to be called as the research framework. This is not a research framework. This is a flowchart as well. Right? This is a flowchart. Okay, this is not a flowchart. This is not a research framework, but this is a conceptual model. Right? This is conceptual model, not a research framework. This model demonstrates the integration of the proposed algorithm with the test specimen model or real system. So this is how you implement your ideas into your whole system. That one is actually conceptual model. Right? This is another example of conceptual model which I did for my PhD student. So this model demonstrates the integration of the proposed algorithm with the test specimen model and so on. Right? So this is only illustration to show the toughness experienced by the student to talk with the supervisor. Yeah. Okay. So this is also another scenario. Okay. You've got seniors, you've got juniors, and so on over there. So this is only my students, Dr. Azma. This one is Dr. Zahira. Yeah. Okay. This one is Dr. Zahira. Okay. Muhammad Nukhirwan, I will answer later. Nukhirwan, Okay. Dr. Hatta, Dr. Nulaili. Okay. And this is the hardcover bound. Okay, so we continue. So now we talk about data analysis. Data analysis. When we talk about data analysis, the purpose is to answer the research questions and to help determine the trends and relationships among the variables. So that is the purpose of having data analysis. And then step in data analysis, you need to understand which data you need to collect. Before data collection, the researcher should accomplish the following: determine the method of data analysis, what variable you want to do, do you require statistician, do you need to prepare dummy tables or whatsoever, and after you have done the data collection, how do you do with the data processing? Are you going to develop something new from the data, or are you going to develop are you going to just extract and do analysis, or what are you going to do with your data? So those are the things which you need to understand when you perform data analysis process. That's why you need to do, after data collection, you need to process the data, doing the data processing, prepare tables and graphs, analyze and interpret findings, consult again the statistician, prepare the for auditing, and prepare for presentation. Okay? This is just to share with you how do we extract from the original process flow in research process and you are now talking about data collection, either you are going to collect data in the beginning of the process, research process, or after, at the end of the research process. When you collect data in the beginning, that one is raw data. When you collect data after you have got the result, that one is collecting your result. So that one is output of the results during the experiment. Okay? Analysis data collection. Method for data collection should be appeared in the research framework. So what category of data, input data, output data from your research? How would you collect the data? How do you buy the data from the source? Or do you get data from your senior? Do you get data from the data book? Or you get data from the internet? Or you get data from your supervisor? All those need to be identified in the first place. If you collect data, or maybe you can generate your own data. So if you generate your own data, how are you going to generate your own data? For example, you're doing artificial neural network, so you need to produce data in the beginning. So you need to know what data you need to generate, or how are you going to collect data, and so on. So what do you want to do with the data? Is it a model derivation? Are you going to identify your parameters, features, variable, factors, or identify your output if necessary? So all those are important things after you have done your data collection, which you need to do for the data analysis. Okay, data collection is an input. For data collection, identify what data you want to collect, identify the data size of data. This is data collection at the beginning of the PhD work, or of the study. Then you need to understand this one. Yeah? Okay. This one, data collection at the beginning, this is raw data. Okay? This one, you need to identify whether it is going to be informative data, and then you need to choose suitable technique or data tools, or instrument, and so on, so that you can get the correct data. And you must be able to identify how many data you want to collect, or variables for the data. Are you going to do data filtering, data cleaning, and so on? Then you need to decide what technique or what tool you are going to use. All those are very important. For data analysis interpretation, create model framework from your data you collected, derive any possible relationships, correlation among the data, and so on. And what do you do with the data? That one is after you have done with the data collection. Derive the model framework from the data and variables, and then perform validation process to ensure correct expected results. Compare your model with the existing models, framework, etc., etc. So data can be confined of several variables. So you got to know the data is a measure on variables of interest obtained from a sample data. Size of the data, variable of the data, and then the data, is it going to be quantitative data or qualitative data? When you have the data, you need to have quantitative variable, and if you are going to have qualitative variable, so you need to use the qualitative data, and so on. So then you need to decide whether the data are dependent or independent. Okay? So this I extracted from Prof. Fazil FSP. Okay? Okay, population. You need to understand about the statistic. The word population is used to design it. The complete set of items that are of interest in the research. A sample is a set of items selected from the population, is a subset, and a parameter is a summary measure for population. Example, let's say mean, standard deviation, they are all parameters. I will explain to you example of a variable. Yeah? Okay. Let's say you got variable 1, 2, 3, 4. They are all variable. Yeah? So this one is statistic. You got average, you got parameter, and so on. All right. Important question at the stage of analysis: how to determine the study, types of scopes of data, sources of data, and methods, and then types of analysis, parameters, analysis stages, analysis technique, application, and so on in study findings and outcomes. So that one will be embedded in the study of data, how the data can be obtained, how are we going to analyze the collected data, and how to end the data analysis. So it shouldn't be open-ended data collection. So if you get enough data, then you have to stop there. Yeah. Okay. So this is actually type of validity test. You can have content validity, face validity, criterion validity, or construct validity. So this one is basically not all are relevant to your field. In engineering, maybe you will not to have data collection be like this. Maybe we develop techniques, we develop theories, equation, and so on. So maybe we don't have this sort of data collection. Eh? Okay, example. So let's say you are going to get to develop an end-to-end artificial neural network as a black box model. So you got data source 1, data source 2, until data source number 5. then you will need different data for different model development. Each model is unique for different problem. So these are called as raw data. Raw data. So the NN as a black box will be used to predict human. So to predict human satisfaction level, to predict voltage stability in a system, to predict defect levels of materials, and then maybe to predict types of disease. So the one is actually the targeted output. The output. This one is output from the model. So the model you develop here, data you collect from the reliable data source. So all data source will be unique or will be usable for the first application. The data source 2 maybe will be suitable for the second application, and so on and so forth. Okay. Example. You would like to predict human satisfaction level. So therefore, the output will be 1, not satisfied, 2, satisfied, 3, very satisfied. So this is your code you're going to put up at the output of the black box model. For example, maybe the black box model is the A and N. So gender is X1, the control variable. X2 is the second control variable. X3 is the age, the next control variable, and X4 is the next control variable. This is when you would like to develop a model in order to identify the satisfaction level of human being. But when you have this model is only unique, or is only suitable, or is only workable to solve this problem in prediction. You cannot use the same model to do something else. It means you cannot use the same model to talk about system stability. Okay, different. This one, 1, 2, 3, satisfied, not satisfied, very satisfied. The second model, 1 is unstable, 2 is stable, 3 is very stable. So you got different set of variables, different set of data, and different set of samples. So that's why the NN is not going to be very generalized. No, it is very unique and suitable only to cater the problem that you are solving right now. Again, the same model cannot be used to do something else. In this case, you got the third model. You would like to use ANN as a black box to predict types of fruit. 1 is orange, 2 is durian, 3 is apple, 4 is grape, and so on. Then you will require different variables, X1, X2, X3, X4, X5, and so on. So all these will be converted to numbers. That one is second example. So to predict defects level of material, so these are all the possible variables, what data to be collected. How do you collect the data? Identify the variables X1 until X4, or data informative or relevant. Do you need to code the data, and so on? Up to you to make your decision. Okay. This is another example to predict timber category in civil engineering. This is example in biomedical or in medical sciences. What data you want to collect to predict types of disease? Number 1 is dengue. Number 2 is Japanese encephalitis. Number 3 is diabetic. Number 4 is hypertension. All those will be numbered next. So this is different model. So the same model cannot be used for predicting voltage stability in power system. The same model cannot be used to predict type category of timber. The same model cannot be used to predict the ripeness level of fruit, and so on. So this is very unique. That's why you need to understand your data, you need to understand the variable, you need to understand the target output, and so this is data collection. Data analysis and interpretation. A credible amount of data has to be collected to allow for a substantial analysis. So you need to decide the size of data. You would like to collect the variable, and so on. Information collected must now be described, analyzed, and interpreted. You have to look beyond the raw data to ask important questions about what the results mean, and whatever they are significant. You have to check the data to ensure that it is clean and look for inconsistency. That's why you need to remove all the outliers, and so on and so forth. Okay, so then you present your results in either a discrete form, if you have bar chart. If you have discrete form or time series, you can also have graphs, and you have numerical values, you can have tables. Okay, this one is numerical. This one is bar chart. Bar chart, this one is bar chart. This one is histogram. This one is not continuous. 3, 4, 5, 6 until 30, they are all numbers which are discrete in nature. We are collecting data independently, one at a time. So that means we don't increase from bus number from 3 menjadi to become 4 until the no. We don't increase bus number. We take all this concurrently or simultaneously. That's why it needs to be tabulated or it needs to be presented in this way because they are not continuous. So this one is very unique for this one. Histogram, the x-axis is not increased, not suitable to be presented in graph form. This is extracted from my this is student Dr. Sharifah Azma from Unit 10. This is table. If you would like to highlight the numerical values, then you can put table lah. Use table if you want to highlight the numerical values, highlight the significant results, and so on. Okay, this is also another example. And this one is actually the graph. So this is the way to present your results to show the profile with certain parameter variation. That means on the x-axis, you got variation of parameters. On the y-axis, you got variation of values. So this one is for multi-objective. This is called as Pareto optimal front for multi-objective optimization. Also sourced from this is from Dr. Sharifah Azma from Unit 10. This is another example. Present your results to show several collected results from rigorous simulations. Okay, this is example of result presentation. Then you explain from what you have highlighted in the dotted column, in the dotted line there, dotted box there. Yeah. All right. And then this one is a pictorial presentation. Present your results to show several clusters from rigorous simulation. So you got this one, you got all the red cluster here, one cluster, second cluster, third and fourth cluster. Then you discuss what is going on. So this is basically the different way or different style of result presentation in your study. So this is just to show you the certificates to supervisors during the holding ceremony. So during that, you can see Dr. Sharifah Azma, Dr. Helmi, and Dr. Hatta from UNIMED. Okay. Okay, almost finished. So we will stop at 11:45. So I will end the talk very soon, and after that I will allow 50 minutes question and answers from you. Okay, why people fail or incomplete PhD? Number one, this is not complete. Number two, fail for plagiarism issues, and number three, correction not done. So I wish you best of luck. So thank you very much for listening and paying attention. Okay, so I will get back to you. So I will stop presenting now. So I would like to welcome any question from the floor. So maybe I will go through the apa tadi, the chatting chat box lah ya. Apa soalan dia? Okay. Airul Syazwani dekat framework. Okay, Prof tengah tengok flowchart. Okay, now we are done. Masih stuck. Okay. What is decision from Muhammad Nur Ikhwan bin Jamal? Ikhwan, what is the difference between research framework, flowchart, and model? Okay. Research framework is the one I show you to show the correlation is a framework which we have everything. Problem statement, objective, and then the activities, novelty, expected result, and so on. Test specimen, all the models, and so on. That one is basically research framework, which you also the correlation. And in fact, you can see the breadth and depth of the whole research work. For you to get a page, that one is research framework. How do you go about? It's not one way like that. It's actually spreading broader and deeper. That one is research framework. And you can have many components inside. You can have the problem statement on the very left column, and then objective in the second column, activities, and then followed by the test specimen, and last one on the very right column, you can see the deliverable or expected result. That one is the framework. Flowchart is a flowchart which you have all the processes involved. For example, process to do optimization or process to do prediction. Number one, collect the data. Number two, read the data. Number three, and then filter the data. Number four, do this one. Number five, calculate this one. Number six, if this one not good, get back to the first stage and so on. That one is flowchart. Flowchart is actually a diagram, component, assembly of diagram which will explain the process of the whole work, whole algorithm. But flowchart, but it's a framework is actually a framework or is a figure which will explain everything which will show the relationship, correlation between problem statement and so on. In the flowchart, you will not see problem statement. Yeah, in the flowchart, you will not see objective, no. But in the research framework, you will see everything there. Then you can see the breadth and depth, whether it is good enough for PhD or whatsoever. What is model? Okay, model is very straightforward. Model is like this. For example, you are going to model human you're going to model human satisfaction level, like the one just now. Then you got variable, you got x1, x2, x3, x4, you got output, and then you got black box in between, you got some components in between. So this is model. So model, you will have variable. Yeah, variable, you got target, you got output, you got whatever components. The whole thing is model or topology. Okay, you can also have framework like that. So now you can see here, F1, flowchart is a process to explain flowchart, to explain the process. That one is flowchart. Research framework is something which is very comprehensive to show all the correlation of all the activities in the system, in the process of doing your PhD work or master's research work. But model is very scientific, very technical, which you must have variable. Just now in the research framework, you got no model. In the flowchart, you got no model. But in the model, you got variables. So in the research framework, you got no variables and so on. Okay, I hope you understand that. What software would you recommend to me as a beginner to familiar with artificial neural network? Okay, Muhammad Nur Ikhwan. So you can use MATLAB. MATLAB now MATLAB those days and MATLAB these days are a bit different. Those days during my time, before 2010, people learn MATLAB. They need to write their own codings in MATLAB, and then they need to call the function and so on. Then they identify the momentum rate, and then the learning rate, and then how many nodes in the hidden layer, how many hidden layers, and so on and so on. This was the previous MATLAB software. And they work in MATLAB. But the latest one, they have the MATLAB people has prepared or has provided the latest block set, which you can simply use, to get a better result. So you can display all the figures for correlation coefficient during the training, during the testing, during the validation process, during the all data. So you can plot them together. I will show you example if you allow now later on. So example of neural network. So sekejap no question. So I will show you some example here. Any question from the floor? If any question, you can basically just raise your hand and you can simply speak out. Okay, I will show you some example. Please, this is 1 minute. Okay, ini for F1. F1. Just now you asked me about neural network. So the latest neural network, MATLAB can help you to produce result like this concurrently, all the 4 results together. This one is the training, correlation coefficient 1.0, the target, this validation process, this one during the validation, and this one is for all result.
Prof, sorry to intervene, but the screen is not shown.
Okay, F1, can you see me now?
Yes, Prof, I can see it.
Okay, F1, now these days, MATLAB can show you this result straight away. Those days, before 2005 or 2010, if I'm not mistaken, you need to get this one by one. You need to write programming codes in order to get this. So to answer your question again, Ikhwan, so if you are going to use, I'm not sure whether you are coming from upper computer science or mathematics or from engineering, Ikhwan?
I'm coming from built environment.
Environment, architecture, right?
Yes.
Okay. So you can use this one now. So if you want to predict, are you going to predict something in your study? What do you want to predict?
Uh, the generation of construction waste.
Okay, good. But remember, if you were my student, so neural network is already there long ago. So you need to do something to make it novel. So if you use neural network per se, that one is not novel. It's already there for being developed by Professor Wollongong maybe 23 years ago back. Uh, uh, Back there. So then you need to do something, make it novel. So you can integrate MATLAB with element of other things, machine algorithm or whatsoever. Okay. So I would like to address question by Izati Isnan. In order for all objective for PhD to have novelty, can the process of development model regime for first objective to be considered novel, Prof? I try to understand what are you trying to say. 1 minute, Izati. In order for all objective for PhD to have novelty, can the process of development of model, okay, when you talk, the process is not novel. But when you talk about something which is measurable, you talk about the technique, you talk about the algorithm, you talk about model, that one is novel. But the process, if you can make, if the process can be verified and can be used to be compared with somebody else process, then that one can become novel. So process is this algorithm, that one is okay, acceptable. Exactly. Depend on how are you going to do it, whether your process is going to be having research element there. Then if you can do validation process, if you can do competitive study, then inshallah you should be able to be called as a research novelty. Yeah. So okay. Screen blank. Okay, any other question from the floor? Ada soalan lagi? Kita ada lagi 10 minit. I know I was going quite fast tadi sebab saya ada 1 jam 30 minit dan I need to cover about 96 pages slides over there. So any question from the floor? Nur Hayati, you got Fahima Idris over there. So if you speak up, you're all lecturers, I suppose. So maybe some of you are lecturers, so you please ask me a question. If you get a question from the floor, I would like to respond to you. Yeah, Uni, Uni, you have any question, Uni?
No,
I cannot hear
Prof.
you. Okay. Yes. You mute lah, Uni. Can you unmute, please? Okay, cakap semula. You can silakan.
No, I'm no question, Prof.
Oh, no question, eh? Okay. Okay, any other question from the floor? Okay, if you got no question, I will show you some example. Some example, how can we identify objectives and so on. 1 minute. I recently read thesis from some universities. So let me show you. 1 minute. Okay. Can you see my PDF file? Yes or no? Okay, thank you. Ardina. Okay. So, okay. So this is an example of a thesis. I recently read the thesis from one research university. So example is when you write a proposal or when you write a thesis, so you need to highlight the novelty. For example, So go through the objectives for this thesis. Okay. When you write the objective, so let's say you write like this, to design something, to design a 5-level cascaded, isolated, multi-level LLC, blah, blah, and so on. That one can be acceptable as objective, number one, as a first novelty. Number two, you can see that to implement the variable switching control to ensure the soft switching. That one is not objective for PhD. That one is actually only scope of work or BAU, business as usual. So I have given the suggestion. So I wrote there to propose a control strategy for solving what, for what to solve what. That one is second objective to become novel for a PhD work. And number three, the original candidate put there to verify the performance of the topology proposed. The one is also not objective for a PhD, not suitable, not novel. It is only a scope of work which you must do as a student. But I have recommended something, so the candidate need to write like to develop a simulation modeling and so on. So this is example, yeah. So this is example, and then you after that you have the this is scope and limited of study and so on. Okay, so any other question from the floor? So I got chat over here. Okay, Izati, I have addressed your question. Okay, Nuh Ikhwan pun sudah. Okay. Okay, so now you understand the flow chart. You understand the research framework and so on. Okay. So maybe you are very tired already. So you are going to have another from yesterday. I understand that. So maybe if you got no question, I will be here until 11:45. So if you got no question, I will pass back the screen to Miss Nazira. Miss Nazira. So the floor is yours, Nazira. Thank you very much for listening. Thank you to all of you. I wish you best of luck. May Allah bless you. Don't stop your PhD within 40 consecutive days. Janganlah berhenti. So yesterday saya baru habis baca thesis. Sorry, my student from UiTM, pasal UiTM Pulau Pinang, Saiful Firdaus, he has finished his thesis. So part-time student. So hopefully you can get through. So your PhD is very sweet. But before you get the sweetness, you need to experience the bitterness first and the toughness and the stubbornness in your PhD research work. Yeah. So look like there is no other question from the floor. Thank you very much to IPSIS for your invitation, for me to share a bit of my experience and knowledge to all the participants, and wish you best of luck. Okay, Assalamualaikum warahmatullahi wabarakatuh. Over to you, Nazira. Over to you, Nazira. Hello, Nazira.
Prof?
Okay, I'm done, Nazira. Thank you very much.
Thank you, Prof.
Okay, jumpa lagi. Okay, Assalamualaikum.
Jumpa lagi.